morning, good afternoon, good evening, ladies and gentlemen, to this session on next-gen, self-sovereign identity for government technology for financial and healthcare inclusion. So I believe that I'm already introduced. So you can find some of my books over here, and my latest book that you can find on Amazon is Blockchain for Self-Sovereign Digital Identity. And I have been working in this space for past 2 years. Um, so first, today's session is about digital identity. So let's start with the issue and the need of global identity for every human, and not only human, also for machines and for animals in future. Because in coming days, we are already aware how the IoT works. So even every human being would be needing more than one identity each for their devices, and even for farming you would be needing identities for animals in future. So that is why it's a huge opportunity. So according to a recent report by McKinsey along with World Bank, there are some 7.6 billion population in the world, and almost 1 billion people globally lack any form of legally recognized identification. So they are called the invisible people, who are mostly women and children from parts of Asia, Africa, and Latin America, and officially they do not exist. Even if they are living beings, they don't have any proof of identity, they don't have any passport, identity card, any kind of birth certificates. So and also there are 3.4 billion who have some type of legally recognized identification, but they have limited ability to use it in a digital world. And the remaining 3.2 billion who have a legally recognized identity, and they participate also in the digital economy, but they may not be able to use that identity effectively and efficiently online. When I say effectively and efficiently, I'll go through it, how the identity works in later slides. So what the world needs at the moment is an efficient digital identity infrastructure that can help to reduce fraud and protects rights and increase transparency. So digital identity also holds the promise of enabling economic value creation for each of these three groups I just mentioned here, by fostering increased financial, health, and educational inclusion. So first, let me introduce you to this digital identity. So what is digital identity? It is any personal data that identifies us online. Like we use our digital identity for onboarding and registration purpose, to websites, any kind of identity management, authentication, authorization, and access to online data, or deregistration. So basically it is needed for initiating any kind of business relationship online. So why we need to protect our digital identity or our personal data is because there has been, since it's a digital age, in last 2 or 3 decades, the number of data breaches have increased many folds, and the maximum number is lying with the breach of personal data. So you can see the kind of organizations who are affected, like Adobe, eBay, and Anthem, and the kind of people who are affected are not hundred or thousands, but in hundreds of millions. The data that got leaked are as crucial as bank details, credit card details, and passwords. Now, why there is a data breach and what are the causes? So the biggest causes are centralized server and weak passwords that we all know. Also, there is a phishing attack. We all know what is a phishing attack, and sharing without permission. That means you are providing your data to an organization, to your even to your bank or even to your healthcare organization, but they are sharing that data without your permission. Or unintentional sharing. Like let's say that you are sending some pictures on Instagram or on Facebook or Twitter saying that, oh, today I'm celebrating my 25th birthday, so people would know that what is your exact date of birth, which is actually a private information, and many banks use this information for identifying who you are as security questions. And then identity correlation. So what is correlation? It's like, let's say that I'm sharing my healthcare data with my hospital, I'm sharing my financial data with my bank, and my educational data with the university. So when sharing this data, then I'm using perhaps my email ID, which is common to all, or maybe my contact number, which is common to all. Then it is also possible that they can use that particular email ID or contact number to know that what is, I mean, it is also possible, like they can correlate and trace back to me that I'm the Johnny, and this is my healthcare data, this is my bank financial data, and this is my educational data. So this is called identity correlation. So we need a model which can actually solve all these issues which is there in the current digital identity system. Now, how we are managing our digital identity, that also has evolved over the years. The first one is siloed or centrally managed identity, which has been there in the market for last 3 decades or more. Like even it's used in many applications today. You are sending your user ID and password, or maybe let's say when you are registering with the website is creating a user ID and password for you. Perhaps you are choosing a user ID, but then the website is keeping that data with themselves. So for each application, you are having a different set of credentials. So they might be using a database or LDAP or Active Directory, but this is the way they are saving your credentials. And then the second one is a federated identity model where the user is actually, I mean, there is an identity provider. So here, there is the server is not giving the information, the credential information, rather identity provider is doing that job. So you are logging into that identity provider first. It's actually responding with a token, then you are using that token to get access to different third parties. So this model works in SSO, this model works in OpenID and all. So in both these models, we have a centralized server, because here in the federated identity, even the identity provider is the centralized server. So these two models are prone to mass hacking and single point of failure. Now coming to self-sovereign identity. So SSI is a new decentralized model to manage the digital identity. Here we have an issuer organization that issues verified credentials. We usually call it VC to the user, that is saved securely in the user's mobile device. At the same time, the issuer is also sending a signed reference hash to a public blockchain, and it's being signed using its own private key. Now the user can share the whole or part of the data to the verifier organization along with the issuer's public decentralized identity. Now the verifier can convert this data to a hash and check if this hash on the data matches with that on the blockchain to know that if it is valid. So this example can be a scenario where the issuer is the passport office and the verifier is the visa office. So the user can share their data with the verifier. So now how it's happening? The users are sharing, in a traditional model, they're sharing their, printed copy of their passport, and the verifier is again doing a background verification. So there is no direct way to know that whether it's a verified credential or not. So with this kind of architecture, we can do that on the spot. And at a later point of day, if the issuer wants to revoke the verified credential, they can send a new version to the blockchain, so that the hash should not match any longer. So the verifier would know that it is revoked, or maybe the shared credential is not valid. So this is kind of the 60,000 feet view of this architecture. But how exactly it happens? Let's go down a little bit and see that how this entire thing works, step by step. Like if some of you want to implement it in real life, how exactly, what are the steps that you have to follow? The first thing is the issuer organization has to create a schema or data structure. Like let's say that the passports office says that these are the data that I'm going to print on your passport. So similarly, you have to create a schema for the VC creation, and the issuer has to create a public and private key pair, and a public date associated with it. So this public date is actually public. So this is date is a decentralized ID. So this is similar to a user ID, but this is public and it is visible to everyone. Like you can publish it on the website. So what the user is doing for each set of VC, the user is creating a public and private key pair and a private deed. So for each VC, there is a separate private deed or private identifier. Now the user is sending her public key and the personal data, like it could be name, date of birth, and different kind of data, personal data, signed with the user's private key. Now the issue, what it's doing, it's actually checking that whether the token is right, so that if what is the actual public key of the user, and then converting the VC to a hash and signing it with its with their own private key and writing it to a blockchain, and the VC is returned back to the user. So that VC is actually a combination of digital data. Now, what the user can do, the user can share the public key, own public key, as well as the issuer's deed or decentralized identity, and a token signed with its own private key, along with the VC. So what the verifier would check that from the token, the verifier would know that because the public key is available. So using the public key, the verifier can decrypt the token to know that whether this is the public key of the user. So and then because it's signed by the user. The second thing it would do is to convert that data to a hash and check on the blockchain that whether it is signed by this issuer, because the deed of the issuer is available. So whether it's signed by the issuer, whether the issuer is valid, and whether the VC is valid. So there are so many things which are verified, and ultimately the VC is verified successfully. So this is the entire flow. So here, and a later point of time, if needed, then the issuer can also revoke the VC. So this kind of architecture ensures integrity of the data, ownership, privacy, and security, and validity of the data are checked. All right. So there are, it's actually, you can see that the SSI network is pretty complex. So what I showed you is only the SSI layer, but then there are other layers also which you have to handle. You have to handle the web standards, the authentication standards. So how somebody is getting access to this kind of SSI network, that also you have to think of an authentication mechanism. Then also open blockchain and a decentralized identity network. So all these things you have to handle on the top. Now let's see how. So there are different layers in SSI. At the heart of it, as I showed you, there is a public ledger, then there is a private and identity storage is there, then agent or hubs. So agents are needed for message transfers, and hubs are needed for having a replication of the data, and then client devices. So there are so many different layers that you have to handle. Let me show you how. So here, you can see that Alice is a user. So she is having a mobile device. So from the mobile device, she can connect to a public DLT. And here she's carrying all her personal data here, which is not only alphanumeric, it could be biometrics data also. And then there is Bob, who is having his personal data in his mobile device. At the same time, he is sharing a copy to a cloud storage, so that later on, if the mobile device is stolen or broken or lost, whatsoever, he can create another copy and revive his position there. Then again, there is a issuer organization here, and the issuer organization is keeping all the data in the cloud storage. So you can keep all your data either in its natural format or in encrypted format as needed. So encrypted would work a little slower, but then it gives you additional security. And then there is a public DLT, which is responsible for creation of all the digital identities, reference hashes for claims, and revocation is also handled over here. So this is the system architecture. Um, Now, how the SSI works in real life. So in real life, there are different issuers. So here you can see, one moment, please. Yeah, sorry. In real life, there are multiple issuers or certifying bodies or organizations. So here you can see there is a hospital where, let's say that Alice is born in a hospital, then she applies for a certificate, or her parents is applying for birth certificates. Then they're producing that birth certificate to the government, and the government is creating a national identity for the child. Then she is joining a school, and she is producing both her birth certificates and her national identity number, and she is getting admission to the school or the university, and finally she is joining an organization where she has to produce all the previous certificates depending upon the requirement, and then she ultimately she passes out from the college or university, and finally maybe she would be joining a workplace. So here you can see there are different set of certificates are being issued by different organizations. So this actually works like a chain, like you are carrying the first certificate to the second organization, then the from the second organization you are carrying it to the third organization, like that. So and each organization can work dual, like each organization can be a issuer as well, and a verifier. So usually they are verifier first and the issuer later. But this is in this kind of chain, the responsibility of the first issuer is maximum. So usually it is good that if the first issuer is a government based organization. So each of this data the user can carry in his mobile device, and as per need the user can share it to different verifiers, and this personal data can be shared in many different modes, like traditional way of sharing, like I'm sharing my name as it is, Devjani Mohanty. The second one is selective disclosure. Like I don't want to share all the data in my passport. Perhaps there is some data, maybe your marital status, or maybe, I mean, what kind of information is a certain kind of information which you don't want to disclose. So then there is zero knowledge proof. That means that you are sharing your data. Let's say that there is a website who doesn't want to, who sells alcohol only to somebody who is above 18. So how would I prove that I'm above 18? Should I disclose my date of birth? But date of birth is a private information, so I would just reply in yes or no, or true or false. And the verifier using cryptology, that can also be checked. The verifier can check that whether the information that I'm providing is correct or not. So this is called zero knowledge proof. And then self-attested. There's some data that doesn't need somebody's attestation. Like let's say I'm sharing my hobby to somebody, so nobody needs to certify it. So these are the three different kind of personal data. And then there is an involvement of public blockchain, where there are different trust anchors. I'll come to that later on. Now let me go through some use cases. So the first one moment. Yeah, the first one is government of Australia. So the Australian government is delivering digital identity program that will allow government services to be easily available to people and businesses online at any time. So their plan is to cover many services through one national level identity for each citizen of the country. Also, most of the paper-based checks would be transferred to digital experiences. So like you can see in the right hand side, so they are going to cover taxation, welfare, health, business, education, social services, banking, etc. So So using the user's biometrics and liveness detection test, the user can be authenticated to use these services. So they are using a decentralized identity model, and this project is still under development. The second one is Singapore, if I'm not wrong. This is no longer in pilot. This might have gone to production. I have to make sure again. So Singapore is authenticating 4 million of its citizens online with facial verification supplied by, there is a organization called iProof. So they're using simple face biometrics check. So the users can get secure online access to government services, and private organizations can also take advantage of this national digital identity infrastructure to authenticate customers online. Then comes Canada. So in Canada, they are providing this project name is called Tell Us One. So users can, the citizens can upload their certificates online, and the government can use it again and again depending upon their requirement. They won't ask the citizens again and again. And on the top of that, the government is also providing certificates to startups. Like let's say there is a startup in Canada. So this project is actually in British Columbia. So let's say that there is a startup, and they want to work with the organization in India. So how, I'm an organization in India, how would I know that whether that organization is fake or real, genuine? So I would trust the Canada government. So that's why I would trust any certificate issued by Canada government to that particular startup. So this is how even India is considering a similar project now. Now, this is a very interesting use case. This is called I Respond. This is again by a sovereign foundation, and they are using Hyperledger India. I'll talk about it slightly later. So here, basically, their model is little different, and this project is actually developed by a NGO called I Respond, and this is developed in a country, I think in Africa, where the mobile penetration is quite low. So what it means is perhaps the users or the citizens do not have smartphones, or even if they have phones, they do not have cameras which can work to implement that kind of model. So in this situation, how they have implemented it, let's see, in especially in third world countries. So in these countries, the number of kidnapping of young children is quite high. So the children are taken across the border by kidnappers, and they are taken to other countries and exploited. So in order to find a solution, what the government has done, they have approved certain NGOs to issue certificates to digital identity to children. Now the child, a newly born child, or maybe a child which is less than 18 years old, they can be accompanied with their legal guardian and or custodian, and the NGO would create, first the NGO would create a decentralized ID for the parents or the legal guardian, and then one for the child, and that would be associated with their iris, because iris is something which is well developed in children. And then because their deeds would be connected and or linked, and then they would be assigned a paper based certificate, and then they can keep it with them as a verified credential. Now, if the child is trying to cross the border at the same time, the border officers would check, whether the decentralized ID is a valid one, and whether the biometrics associated with that is matching with the child and the custodian who is escorting the child. And again, there would be a need of a consent by the legal the guardian. So if all these things are working fine, then only the child can would be able to cross the border along with the legal guardian. So this is the use case which is under development. Now, wait. So digital identity is the hot cave of today's world. You can see in the picture how most countries in the world are doing some research or other. Like here you can see there are so many initiatives, but not all of them are decentralized. But like I said, Australia is working on it, Singapore is working on it. And then there are certain countries in Africa, UK perhaps is working on it. Government.uk is working on verified credential. British Columbia in North America is working on it. So many of these countries are working, and not only that, they actually can um, they help to implement the privacy laws like the GDPR, PDPA, PDPB, etc. And by implementation of SSI, you can actually adhere to all the standards. And also by year 2023, 65% of the world's population will have its personal information covered under modern privacy regulation of from 10% today. So if you ask me that what is the area of blockchain which should be used by each and every person on earth in one day, then it would be, I mean, or maybe in 5 years, maybe then it is digital identity or SSI. Then I'll cover some area of research in SSI. So there are so many SSI protocols available in the market. So Hyperledger has got its own a protocol called Indy and Aries. Ethereum has got Civic and Uport, and Microsoft is coming with Iron, which is still under development. And currently working with EarthID, and we are using Hashgraph. So these are the different protocols, and there are many more. You can visit W3C site and you can find many more possible SSI protocols. And you don't have to abide by any particular one. You can just see that which one is suiting you. So this is the architecture of Authentication that I'm currently working on. So here you can see in the right hand side we are using Hashgraph, but you can use any of these.
Amazing.
Sorry. It's some. Okay, so here you can see that in the right hand side we are using Hashgraph, but you can use Hyperledger Indy over here or Ethereum over here depending upon your project's needs. And also you can see in the left hand side we are not only creating this kind of architecture only for human beings, but also for IoT applications, IoT devices in future. So this is the roadmap, and also like I said, the user's data, personal data, can be saved on device, or it might be stored as a copy on IP address. So in that area also we are working. So what are the different SSI success factors? So how do you know that your SSI project is successful? First of all, you have to know that what kind of cryptology, what kind of public key infrastructure that you are using, whether it's scalable, your solution is scalable, and whether the throughput is good, because unlike B2B blockchains, the SSI needs, the requirements of SSI is very different, because you are trying to cater to the needs of not hundreds of thousands, but millions or billions of people. So that is why it has to be scalable, extremely scalable. The cybersecurity should be good enough. It should be interoperable, so that even if you are on different platforms, somebody is working on Indy or Iris, somebody is working on Ethereum, somebody is working on some, like we are working on Hashgraph. So there could be different blockchain platforms, identities created on different platforms, but still they should be interoperable. What kind of data sharing technology are you using? How effective they are? So like I already discussed about selective disclosure and zero knowledge proof. Who are your validated nodes? So what it means that, so the consensus model, because this is SSI is associated with the blockchain. So that blockchain should not be something like Bitcoin or Ethereum 1, where we have proof of work, which is extremely slow, and so you cannot work on that kind of technology. So what you need is proof of stake model, which is faster, and also you need to make sure that who are the validator nodes, or who are your stewards, or who are your custodians of this kind of DLT. So that is also is going to bring trust to this network. And then of course, how you are giving access to the SSI network to your different users. Is it again through user ID and password? Is it through OTPs? Now how you're doing it? So the best model is integration of biometrics. So like here in our architecture, we are using SHA-256 for hashing, and ED25519 as public key signature system, which is fastest and safest at the moment. In terms of scalability and throughput, Hashgraph is tested with 10,000 transactions per second and 1.5 million transactions per day with finality in seconds. Then cybersecurity, Hashgraph is a resistance against DDoS, Sybil, and spoofing attacks. Then in terms of interoperability, it can be easily integrated with other DIT networks. And selective disclosure and zero knowledge proof, we are trying to cover each and every possibility, like greater than equal to, less than equal to, greater than, less than. So when it comes to validated nodes, Hashgraph's validated nodes are industry leaders in different verticals like Google, IBM, Wipro, Deutsche Telekom, FIS, Tata Telecom. So these are the validator nodes or stewards or the students of Hashgraph network. So in that sense also, this is good. And integration of biometrics, we are trying to integrate with different kind of biometrics, which are physiological as well as behavioral. So we are trying with face, we have already completed. We are also trying iris and fingerprint. And in future, we have the plan of implementing, palm vein and gate and voice. So these are in pipeline. So these are this architecture of SSI architecture of Earth ID. Now I'll just cover one use case, which is next-gen authentication and authorization architecture. I think that most of you might have heard of FIDO. So FIDO is on-device authentication without the need of OTP or password. So now we are gradually moving towards a passwordless model. But what I'm discussing is even ahead of it. I'm going to discuss decentralized biometrics. So first we need to understand a little bit on why this is needed. So what are the different personal data management methodologies as of today? How are you getting access to your online data? So there are three different ways. One is knowledge based, one is position based, and then inheritance based. The first is knowledge based. That means you know your password, so that is why you are who you claim to be. Or maybe you are able to produce a OTP, or maybe you are using a hybrid model among these two. You're providing a password as well as your OTP. Second one is your position. That means you purchase a smart card. So that is why you are what you are claiming to be. Or third one is, so because this knowledge and knowledge, your password can be stolen, your OTP can be stolen, your position can, your smart card could be stolen. But the third one is inheritance basis. So that means something which is God given. So your inheritance is your biometrics. So that is why biometrics is considered safer than any other previous technologies. Again, people are coming with hybrid models, like you might have heard about biometric cards for payment. So there are banks who have started allocating this kind of cards to their customers. Now, how biometrics works, I believe that most of you might have some idea how biometrics works. One moment, please. Yeah. So first, we use a scanner to scan the user's biometrics such as face, finger, iris, retina, palm vein, etc. Then we extract some unique features out of that biometrics, that image, and map them and save them as biometric templates. So biometric template looks like this: 0 and 1, 0, 1, like that. So it's binary. And we save it to a template database. This part is similar to registration, where we can create a unique user ID and password. So at a later date, the user can log in using the same biometric, and the system matches it against the biometric database it has. So this matching is little different from matching user ID and password. So this biometric actually the matching would come up with a score, like what is the probability of matching, what is, I mean, is it 90%, is it 50%, is it 40%? So on the basis of some threshold value, you can finalize whether the biometrics is matching. So again, wherever there is biometrics, there is spoofing. So spoofing is a method of fooling the biometrics identity system, where an artificial object like the fingerprint mold can be used. Fingerprint mold, I don't know how many of you have heard of it. You can also create a fingerprint mold out of silicon, and you can present it to the scanner. So how would you make sure that somebody is not using a 3D mouse or a photo or a video or others, like makeup or surgery? So there is a sensor associated with the camera, or maybe there is a challenge which is asked, somebody is asking you to do, like the app can ask you to smile or change your facial expression from happiness to sadness, and do some head movements. So this is called active liveness detection test, so which you have to do, the mobile device has to do. Then also there is passive liveness detection test, where there is algorithm, ML based algorithm, which would check that it is a real person and not a 3D mask or a video or something. So so there are different anti-spoofing technologies. So SSI along with biometrics have been have become very popular nowadays, and there are companies like Q Ledger, which is a credit union in US. They are using this kind of combination, but actually it is not decentralized biometrics. They are using biometrics for on-device authentication, which is FIDO based, and then they are using SSI for data sharing. And then there is Gemalto and Thales group. They are also doing a very similar model for their banking clients. So here in Q Ledger, you can see once the user is logged into the credit union, then all the banks which are associated with the credit union, they can also give access to the user. So it works on an SSO model, but here there is no centralized storage like that. So now let me show you how we are working on a decentralized biometrics model. So this is pretty interesting. So here in Auth we are handling different kind of biometrics templates. Like we have completed work on facial biometrics, but in future, like I said, immediate future we would be working on iris and fingerprint, and we have planned to work on behavioral ones. So in Auth first the user captures the biometrics after active liveness detection check and converts it to a template. Then the user sends the data, the personal data, that means it's and the biometric template. So it could be like your name, your date of birth, all these things along with the biometric template to a issuer organization. Now the issuer organization can optionally do a background verification or deduplication if there is a need of deduplication, or there is a need to save the template, like something like a national identity program. Then they can do it in a centralized biometric template database, which is not a mandate. So you can completely ignore this step. And then the issuer would convert that data to a hash and signing it with the issuer's own private key. The issuer can write it to a public blockchain. Then the issuer would send back the VC and a confirmation. So on a later point of time, if the user wants to log in, the user can log in again with biometrics, which should again undergo liveness detection test. And then the user can send all this data, the personal data as well as the live biometric template, and the issuer details, that who is the issuer who has certified this. So now here the verifier could be the same organization or a different organization. So now this model would, please note that this model would work on the fly. So that means that because there is no centralized database over here, so any organization can come and check. If they trust the issuer organization, then they would trust the user, and they can get access, they can give access to the user to their ecosystem. So then what they do, they might do a passive liveness detection test on the biometrics data if needed. And then they would convert the personal data to biometrics to hash and match the hash with the the one provided by the issuer. So the issuer is validated and the VC is validated and the user is also validated, that whether the same certification has been allocated to the user who is carrying the same public key as they are sending a token also here. And if all goes fine, then the user is authenticated. So yeah, so this is the model that actually most of the work is done for face as of now, where we are also trying with the finger, and maybe in future we'll be coming up with more. um, so I think I'm done with my presentation. You can read more on blockchain for self-sovereign digital identity.